Try to pop them again.
No. All right. Anyway, so we have a pH gradient right here.
Oh or no?
No. No. All right. So, okay, so we have a pH gradient right here, right? So the differences in concentration. You don't need to worry about the specifics of this right here, but essentially the differences in concentration of the hydrogen ion. So the differences in acidity is what's going to cause your ATP synthase to go. Your synthesis of ATP. Okay. So production of ATP is going to be a result of your change in concentration, right? So things are going to be pushed to balance out the concentration gradient, and as a result, you'll have a production of ATP, right? So we won't talk about the specifics of that, just because you'll get bogged down in those details, and it's kind of confusing and not entirely relevant right now, okay? So let's talk about, okay, so let's do the Krebs cycle, okay? So, pyruvate produced in the cytoplasm moves through both mitochondrial membranes to the interior of mitochondria, okay? So, what that means is, so what happens at the end of glycolysis? What are your products?
36.
No. Glycolysis, just glycolysis. 4 ATP, right? 2 net ATP, right? 2 pyruvate molecules, what else? 2 NADH, right? So at the end of glycolysis, that's what you have going on, okay? So we're here at the end of glycolysis now. We're going into the Krebs cycle. So from glycolysis to the Krebs cycle. We took a detour with aerobic respiration just to talk about how that works out, okay? Don't worry about aerobic just right now. We're back to anaerobic, okay? So we're in the Krebs cycle. Pyruvate produced in cytoplasm moves through both the mitochondrial membranes to the interior of the mitochondria, okay? So the pyruvate in your produced through your glycolysis, right, is going to go through both your mitochondrial membranes to your interior mitochondria, okay? So that's where your Krebs cycle is going to occur, all right? Okay. All right. So the Krebs cycle, you have pyruvate plus CoA. That's going to be an enzyme. It's going to be called coenzyme A, all right? Plus NAD plus yields acetyl-CoA plus CO2 plus NADH. Now that's a lot and it's kind of complicated, right? So essentially, acetyl, you have acetic acid, I think, I'm not really sure what it is just yet, but it's going to combine with coenzyme A, that's going to produce acetyl-CoA. Your carbon dioxide is going to be produced from pyruvate, right? Cuts a 3-carbon sugar, and it's going to yield a 1 carbon. And NADH is going to be a product of NAD+, okay? That's where that comes from. Okay, so every acetyl-CoA, 3 NADH, 1 FADH2, and 1 ATP are produced, okay? So let's go back into see how the cycle works out, okay? Okay. So, again, this is complicated, guys. I know. It takes a while to learn. Right now we're just here to understand the cycle and then figure out the numbers so we can answer some basic questions. Okay? What? Yeah, no, trust me, it'll make more sense in the end. We're going to go over a few times, alright? Yeah?
What's that word between acetyl and...
It's acetyl-CoA, acetyl-coenzyme A. Okay? So it stands for. Alright. So, rinse water.
Where'd you get those cups?
Okay. So, guys,
you can get a cup.
we start off with glucose, right? A 6-carbon sugar.
Anybody can
During
get a cup.
glycolysis, we got our 2 pyruvates, right? Which are both 3-carbon sugars. Okay. From here, we convert to 2 acetyl-CoA. Those are both 3-carbon sugars, okay? So it's just converting it with acetyl and CoA, that pyruvate turns into acetyl-CoA, okay? During that process, you produce 2 NADH.
Folks, if you have
okay?
a car parked in the band grid,
So,
know
keep
who
in mind,
you are,
right now,
and
we're
move
right
your
here.
car immediately.
Okay?
Thank you.
Right here, we have 2 ATP and 2 NADH from what? From what? 2 ATP and 2 NADH from what?
From glycolysis.
Glycolysis. From then, when pyruvate converts to 2 acetyl-CoA, you have 2 NADH produced again. Okay? Then you go into the Krebs cycle. That is a whole mess of different transformations of carbons, but we're not going to worry about that right now. Okay? So in the Krebs cycle, we just know that we reproduce 4 CO2s and 2 ATPs. Okay? For each acetyl-CoA that goes through. Okay? So for each acetyl-CoA that goes through, we have that. or for those two acetyl-CoAs, we get that, okay? 4 and 2. So from there, we produce 6 NADH and 2 FADH2s, all right? For each acetyl-CoA, this right here, we produce 3 NADHs and 1 FADH2, okay? All right, so right now, we're right here, okay? At the end of the Krebs cycle. All right, so I'll give you a moment to write that down maybe. Here at the end of the Krebs cycle, what's in a box is going to be what are our products so far, all right? So we have 2 ATP, 2 NADH from the glycolysis, right? 2 NADH from pyruvate transforming into acetyl-CoA, 4 CO2s, 2 ATPs from the Krebs cycle, 6 NADH, and 2 FADH. Someone add those up and tell me what is our net NADH right now? 10 NADH, right? So 2 plus 2, 4 plus 6, 10. How many ATPs do we have? 4, right? So here, let's keep a running total right here. So we have NADH, right? How many NADH? 10. How many FADH2s? 2. How many ATPs? 4, right? Okay. So right now, understand, you guys, understand that this right here, these are all carriers of energy, okay? NADH, FADH2, those have energy as well, okay? ATP is what we want though, right? Because ATP is the most efficient, it's the nicest, it's pretty legit. Alright, so from the Krebs cycle, we're going to go on to electron transport chain, okay? So the electron transport chain is basically going to be a huge chain of a bunch of different molecules and lipids and just proteins and a lot of stuff, right? And it's gonna at the end give us what we want. Okay, so that's all we want right now. What to know? Okay, the electron transport chain, as it implies, is going to transport electrons. All right, so let me set this a little bit. Okay, so is everyone cool with the cycle beforehand? And hey, so once we go through the whole thing, we're gonna go again and look at the details, okay? And it'll be more clear, okay? All right, so don't worry about getting all of it right now if you don't understand. All right, so the electron transport chain is going to be a series of proteins and electron carriers located in the inner mitochondrial membrane. So the inner mitochondrial membrane makes sense right now, right? Because at the end of the Krebs cycle, we were at the interior of the mitochondria, right? Right? Yeah, right. Okay, cool. Okay, so that's where we were. So now the electron transport chain is going to be on the inner mitochondrial membrane, which basically means those little folds in your mitochondria that you have going on, right? That membrane right there, that's where this stuff is embedded. Okay, it's not suddenly an electron transport chain. It's just, for our purposes, it'll transport electrons right here, right? So, right now we have 10 NADH, 2 FADH2s, and 3 ATPs, or 4 ATPs, right? So, the NADH, FADH2 transfer their electrons and are oxidized to NAD plus and FADH plus, right? Because if I take out a hydrogen, basically I'm taking out an electron right now, it'll become a plus left, right? All right. Okay, so the final electron acceptor is oxygen, which is reduced to water. ATP synthase found in inner mitochondrial membrane is, okay? Okay, so now let me draw you a picture. All right. So far, are these all the molecules we have talked about? Has anyone noted anything else? Check that out. Our running list of molecules right there, is that all, or do we have any more?
We get some CO2s, yeah.
CO2 is okay.
Not sure.
Anything else? Yeah?
What's FADH2?
FAD right here is going to be an abbreviation for a molecule.
Okay.
The H indicates hydrogen. Alright? But for our purposes, it's just going to be an energy carrying molecule, right? Alright? So, our electron transport chain is going to be something like this. Don't worry about drawing this right now because it's a very crude drawing. Alright, so that's O2 right there, right? Our oxygen. Hey, someone tell me again what our original equation for cellular respiration was. The very original _1 equation. So we had glucose C6H12O6, right? Plus what?
Plus 2.
O2 yields what? H2O, okay, plus what? Plus what? ATP, right? This will be an unbalanced equation right now, okay? Because it's obviously not balanced. Try and unbalance. Alright, so far we have already transformed, which of these guys? We've already transformed, have we transformed glucose?
Yes.
Yes.
Yeah, that's gone. Have we transformed oxygen yet? No. Have we gotten water yet? No. Have we gotten carbon dioxide yet? Yeah. Have we gotten ATP yet? Some, but not all. Right. Okay. That's where we are right now. Okay. So this is your transport chain right here. Okay. So key to remember. So right now we have NADH and FADH2, right?
Yeah.
Okay. So those will go through your electron transport chain. Like they'll basically go through this passage right here, release their electrons. Okay. They'll give their electrons to oxygen. All right. Okay. Oxygen becomes water. Oxygen becomes water right there.
Yeah.
Okay. NADH becomes what? NADH goes to NAD plus. FADH2 goes to FADH plus, right? Basically, take out a hydrogen from both those.
Now I'm going home.
So they release their electrons. Now, here's a cool trick. For each NADH2 we had, we get 3 ATP. Okay? For each FADH2 we had, we get 2 ATP. Okay? Sound good? Okay? So, how many ATP do we have now? If we get 3 for NADH and 2 for FADH2, how many years of ATP do we have left?
9?
No. We get 3 for every NADH we have, right?
Oh, yeah.
2 for every FADH2 we get. So 3 times 10 is?
30.
Plus 2 times 2?
4.
34, right? Plus 4?
38.
38. Whoa, cool. Hey, 38. All right, so yeah, we can cancel this out, and we get 38 ATP in the end, right? So now you understand how we get the ATP, right? It goes through a whole mess of steps and then gives us ATP, and oxygen turns to water, and glucose goes to carbon dioxide, and we have ATP, right? So now let's talk about how that actually happens. So we're gonna backtrack again and go through it again, but this time you know what to expect, right? So you know what's gonna happen, how the numbers work out, and you can kind of figure it out and understand it more. So yeah.
Can you speak a little louder because I'm not sure?
Yeah, I can.
Yeah, I can't.
Okay. So we start off here with glucose, right? Glucose is a what? What does a 6T tell me? Okay, so I need input from you guys this time, okay? Because I don't know how to do this, right? So let's just go through all of it. Well, that's cool. All right, I guess it didn't again. All right, so glucose goes to 2 pyruvate, right? How do we know this is pyruvate? Because 2 times 3 is 6, right? We don't want to lose any molecules, guys. So at this step of glycolysis, we yield 2 ATP and 2 NADH, right? Right. Okay, now we go down, all right? So we also yield 2 NADH from our conversion of pyruvate to acetyl-CoA, right? So we got the Krebs cycle. The Krebs cycle gives us 4 carbon dioxide. So now we have glucose and carbon dioxide, right? Okay, glucose to CO2, glucose to CO2. We're done with glucose now. Okay? Glucose has given us all of our energy that we need at the point. So we have that ATP, NADH, and NADH, right? Right? Go through the Krebs cycle. Then go down. We get 6 NADH from the actual Krebs cycle and 2 FADH2, right? So total glucose is gone. We have 2 plus 2 plus 6 is 10. 2 is 10, or 2 is, sorry, 2, I think 8 is just 2.